Welcome back, everyone. This is John from Cloud Tech Insights. In the previous session, we learned how the strands works and how a model-driven approach works. And in this session, I want to focus on how to use strands in a practical sense, like connecting to different databases and tools within AWS and orchestrate a Gen AI use case. In this session, we'll be deep diving into a specific use case where we focus on restaurant booking, which means you can browse, chat with an application, find a restaurant, and then you can book a reservation in the restaurant in an agentic way. So this is one of the use cases where you do an end-to-end GenAI applications, connecting different AWS databases, tools, knowledge base, and form a complete GenAI application using AWS Strands. The code we use in the session is publicly available in the AWS samples GitHub, and you need either a local installation of Visual Studio Code with AWS connection or a Sagemaker Unified Studio Jupyter Lab notebook where you can simply run this code and see how it works. Ensure that you have access to all the databases mentioned in the code, and I will provide the link for the GitHub below in the description. With that said, let's see how the strands interact with different AWS tools and databases and build a complete GenAI application. So very first step, we go to the Strand Agents GitHub page and go to samples under tutorials, go to the restaurant assistant page, and I will provide this link in the description. And in this repository, open the notebook. And once you open the notebook, you can see how the architecture is built. So this is where we are building a restaurant assistant agent where it helps you browse for the right cuisine. And once you find the restaurant, you can just book the table and go for the reservation. So when the customer interacts with the restaurant agent, assistant agent here, the customer puts in a question. It has different tools available, one for creating booking, one for getting the booking details, and one for deleting the booking. And there's another tool or a task that it can do, which is retrieve information from the knowledge base, which runs on OpenSearch and which is loaded with information from documents from S3 bucket. So basically the chunking happens here into OpenSearch and the knowledge base is built on top of it. So it knows what restaurants to look at, etc. And then we have the access to the Bedrock LLM models where you can immediately, the chat agent can send the response and get a response back and figure out what tools to use and when to use. And all these booking information is stored within DynamoDB table. So there is an option to create a booking, get the booking details, and delete the booking tables within the DynamoDB table as a tool. So at a high level, the agent is pretty much able to interact with different databases, different knowledge bases, and it can interact with the LLM model for providing the right response. And this is again a model driven. A model decides what tool to use. You don't have to specify what tool to use to book table or get the booking details or delete. It decides on its own. So that's the beauty of a model driven approach. And ensure that you have the Python 3.10 and above, all the information, and you have a couple of options to install all the dependent library. And then there is a deploy.s prerequisite sh. This creates all the DynamoDB knowledge base, OpenSearch, and S3 bucket, and chunk the data and put it into the knowledge base. So keep in mind some of these require your account to have some of these tables created, and you should make sure that you have the access, and this is going to cost you based on your usage. So keep this in mind before onboarding to this ecosystem. And you can see the prerequisite, which I would highly recommend to run. Basically installs all the required libraries that is not there in the notebook, and it helps you install the strands library, connector libraries, Boto3, CLIs. All those information will be under requirements.txt. And once the library is fixed, you can run this deploy.sh. And this is going to create some of these instances of DynamoDB table, knowledge base, OpenSearch, etc. So you got to make sure that you run this before executing any of your programs. So once this is done, you can start running the notebook. So the very first is, oh, my bad. So you import the libraries first and then set up the DynamoDB table. And so this helps you create the DynamoDB table, the knowledge base, etc. And the next step is the defining the custom tool. So like I said before, get booking details, create booking, delete booking. tools available, and you can start defining some of these tools in a function format and make sure that you put the tool decorator right above the function so that it understands that these are tools. So you don't have to specifically say it, and you can build some of these tools and in the notebook, or you can create a separate file where it can write to a delete booking.py and you can import this file separately. See, these are the things for creating and deleting booking. Now the tools are created, these are separate files, and you can now import these .py into the notebook. Once you import, now you can start creating the agent. The agent has a clear prompt by saying that you are a restaurant helper and you reserve tables for different customers, and you can go through this prompt and understand how it works. So it gives the exact instruction on how this agent should behave and what are the step-by-step instruction it should use in order to make a reservation and browse through the cuisine, etc. And once that is done, now we are calling the Bedrock model using the Claude 3.7 sonnet. Again, you can use a lighter model, but in this example, we are using Claude 3.7. And then we are creating an agent here and now asking the question, San Francisco, where can we eat? San Francisco. So let's wait for a response back. And he or she is using the tool retrieve from the knowledge base. It's going to the knowledge base with the open search and figuring out what are the good restaurants around San Francisco. So there is a place that it recommended called Rice and Spice. It's a Pan Asian fusion, and these are the different cuisines or the dishes available. And you can also see some of the agent results, analyzing how it analyzed some of those results. So all these informations are available in the method called messages within agent. So that gives a detailed explanation on what it searched for, what are the knowledge base retrieved, and out of the knowledge base, how did it retrieve that information. Now I'm going to say at 9 p.m. I want a reservation for 2 people under the name John. And let's see what it does. So now the agent is figuring out what tool to use to make that reservation. So it used to get the current time, and now it's going to ask more questions about the reservation, which reservation would like. So it clearly tell you what where the reservation is made, and it also tells you that 2 people at 9 a.m. is booked under the name John. So it's pretty much runs some of those tasks independently. It stores the booking information in a DynamoDB table. And if you want to create or retrieve or delete that reservation, you can go ahead and talk to it. We can also say, I delete my reservation. Oh, my bad. Reservation for John for 2 people, 9 p.m. at Rice and Spice. So now it's asking for the booking ID number. So this is how you can create a reservation, and if you have to delete, you can provide the booking ID number like that you receive in your email and provide the booking ID number. It automatically deletes your reservation for 2 people at Rice and Spice. And this is how the agent works independently. And you can look for the agent and runs the task behind the scene, creates, deletes your booking, and make decisions on its own to use what tools to do that particular task. And you can always look at the agent messages to see how it worked behind the scene, and also the metrics, how many tokens, what tools used, all the information will be provided, the time taken, error count, all the information can be retrieved using the method dot metrics. And the messages shows clearly on what user, what was the question, what tool it used, and what content it retrieved from the knowledge base. All the information is provided in the messages method that you can invoke by calling agent.messages. And this piece of code shows the DynamoDB table entry. You can always go to the DynamoDB table and see some of these entries right there. You can see some of these reservations that's been entered in the DynamoDB table, or else you can look at it through this code, and basically you can see the entries made, deleted, etc. And once you are done, you can clean up the entire system or the tools and databases that you created using the cleanup.sh. And this helps you avoid unnecessary charges in your AWS account. So it's executing one by one, deleting all these open search, all these information, databases, knowledge base, etc., and cleaning up the Bedrock ecosystem as well as DynamoDB tables. With that said, I'm wrapping up the session. In the next few sessions, we'll explore some of the other agentic operations that we can do with AWS Strands. And if you like this video, please hit the like button and comment below on what you want to see in the next video. With that said, signing off, John.